everyone, welcome to this episode in the Finding Your First Bug series, and actually it's the penultimate episode. There'll be one more episode after this, and that's going to be on Impact, and then this is it for the series. I've always wanted to finish the Finding Your First Bug series and make it a finished, not tutorial series, but a finished series to be like, look, if you want to find your first bug, here's the videos you should start with. I didn't really want to turn it into Finding Your First Bug, SSRF, Finding Your First Bug, RCE, Finding Your First Bug, how to chain 30 different exploits together for 100k. So I was always going to end it, and I think I've covered most of the beginning bugs I want to cover. But anyway, off topic, what is Cross-Site Request Forgery and why am I doing it? So this video is about CSRF, Cross-Site Request Forgery. And this is definitely one of the more technical bugs I've covered, since I kind of shooted through XSS because I think XSS is not a bug you're likely to find anymore. So this is going to be a bit more technical. I have got a demo, so hopefully you guys can fully understand it. So what is CSRF? So CSRF abuses the fact a user is logged in to perform actions on their account. So what does that mean? Well, when you have a web browser, and you press remember me, your browser will save the cookies and use your cookies whenever they access that website, so you don't have to log in every single time. So how do we abuse that? Well, if we create our own website that links to that website, without the user knowing, we can actually perform actions on their user account by accessing different parts of an API or different endpoints. So because they're logged in, even though they're visiting our website, actually the actions will still be performed, and we can almost perform actions as a user. I know it's a little bit complex, but we'll see how that works in a bit. So you also have CORS, and it's really important when we talk about CSRF to talk about CORS policy and same origin policy. So what are these? These are policies that your web browser has, which restricts whether or not you can call one website from another. So if you've got mywebsite.com and you make a request via JavaScript to google.com, should that be allowed? Should that work? Now, depending on what the cross-origin resource sharing policy is, yes, or no. So by default, we have the same origin policy. What does that mean? Well, here we've got this web browser is accessing 1.html. Now, anything on a.com is on the same domain as this web browser is currently on because they're both green. But b.com is a completely different domain. So we need to have some kind of link here to allow the cross-origin resource sharing, the CORS. So that's a basic concept that exists in web browsers. This is not actually a defense against CSRFs. It's a defense against receiving data back from a CSRF. So you can actually make a CSRF account without violating the same any origin policies, but you won't be able to read the data back. So if you have a API that just edits something, you won't get an error for the same origin policy. However, if you're trying to return information back, you'll be violating the same origin policy. However, there are other bugs that you can use to violate that, and I'm not going to go into them because they're quite advanced, but this is just some technical implementation of what it works. So if these work like this and you can still access them, how do you prevent them? What tells you it's impossible? So if you see a very restrictive CORS, so what you'll see is cross-origin resource sharing star, or a bunch of different domains, that will usually tell you that you cannot read the data, you can only send it. And it's not necessarily write access, it's just sending data into the void. And then the SOP, the same origin policy, is when there's no CORS at all. And once again, that is the same. That is, you cannot read the data from the CSRF, you can only send it, and it doesn't protect against CSRF. So, CSRF tokens. So these are the primary way to protect against CSRF attacks from a developer point of view. They generate by a web server on a page as a hidden input, and they're validated by the server on the next page. So, okay, let's have a look at this visually. So, you're a user and you want to change your address. So you have a form that's changed your address. This is what the web server is kind of doing in the background. So you tell the web browser you'd like to change the address, and the web browser loads up this page, change address. But what it's actually doing is also generating a CSRF token on that form. So it generates it and it puts it into the form, and then before it loads it to the user. So we've got all of our address columns and then this hidden input called CSRF token. So when the user fills out the form, the web browser checks asks if the CSRF token matches, and the web browser confirms it. So the web browser will then process the data and change the address dutifully. So what about if you've got a malicious user? So you go straight to the server and say you want to change your address because you want to avoid the web browser, because you're playing you want the victim to never notice. You have to communicate directly with the web server. So the server will then ask, where's your CSRF token? And if we give it an invalid CSRF token, it just won't process the data. So that's kind of how that works. Okay, so let's have a look at a short demo. So this is something that I built. I use Laravel to make it. So I've got an account here. I think I've changed the username too many times. So I'll make a new account. And I'll put in Katie. Email address is f.f.com. Password is 123 1234 123. Bloody hell. Right, now the cookie has been saved on my account. Okay, so let's first have a look at the change your email function. So I can put in a new email address here and submit it, and then it just changes the email address. Okay, this is a GET request and has no CSRF protection. So we're going to have a look at this lovely CSRF attack. So if we want to abuse this GET-based CSRF, we can put it in an image that loads on the web page. Even though this image doesn't exist, it will still run the code. So if we then load up GET, so notice that the email is, and I just loaded it by accident. Notice the email is fff.com, and when we press GET here, it will load up this image and it'll be a broken image. But what it's actually doing is, because it's loading up the endpoint over here, so as you can see, the email then gets changed, and now it's the email that we had put in on here. So we can change this to whatever we want. And for an email address, this is really important, because for an email, what it gives you is an account takeover. You can do, I forgot my password, and get it sent to you. Okay, so this is an example of CSRF without any post protection. So we can put in our color here, submit it, and our color is blue. Okay, so we go here, and we want to do I actually forgot what color I put in for post. So this is our post value pink. So here what we do is construct a form with the action sending it to our other web page, and then each of our inputs are whichever name they're expecting as an input. And then we submit it automatically, so that way a user doesn't have to press a button. So we do that, and the CSRF has worked. Okay, so what does it look like when it doesn't work? So if I change my name here, that worked. And if I go to my CSRF demo, you'll see we get a page expired. Now that's you don't have the right CSRF token to work. So that's a really simple example of how you could actually exploit this. So let's have a look at let's go back, and I hope that's been a little bit easier to kind of explain how that works. And I will make the code for the payloads available in probably the description, so you can use those payloads for your own CSRF if you would like. Okay, so we had a look at doing this from the browser side. What does it look like when we put it in Burp? Well, they just tend to have these like little underscores called CSRF tokens. Sometimes you get kind of weird ones. It will depend on what kind of application you're hacking, what you see. So if I go back to my demo quickly, if we look at this form here, this one's just called underscore token, and it's here, and that's our CSRF token. So you'll see these everywhere, and once you get to see like the general like layout for one website, what a CSRF token is, you can start to look for endpoints that just aren't sending one. So that's sort of what a CSRF attack is. What is the impact of CSRF? Well, it really does depend on the function of the web app. If we can do something like change a user's email or password without them knowing, we can really take over their account, and I'll show you an example of that in the case studies. And if we can do actions on behalf of a user, impact really depends on what the app is. An app like PayPal being able to send money to themselves without someone knowing that we've done it is obviously quite a lot more powerful than being able to, I don't know, change someone's favorite color from blue to pink, right? So what makes them great first bugs? They can be fairly simple to spot. You just have to look for a CSRF token not being there. And most of the security impact is dependent on the web app, not necessarily the technical sophistication. Once you understand how to exploit a CSRF bug, you know how to exploit every CSRF bug. So you don't necessarily have to learn like a shit ton to be able to do it. You can mostly just focus on, okay, which ones of these have big impact. But Professional can automatically generate CSRF POCs. That really helps. However, they're not really difficult to write if you have programming experience. Mine will be in the description if you want to use that. Or you can Google CSRF POCs or POC generators. It's all, it will all do the same thing. Right, so how do you find them? In summary, step 1 is look for a form that is not sending an extra token. These may be called CSRF token, CSRF token, underscore token. All of this stuff means that it's not vulnerable to CSRF. You then need to ask yourself, is the form not asking for confirmation of an action? So, e.g. to change your password, you need to type in your current password. When you have something like that as like an extra factor, really, with the CSRF, you can't really explain it unless you do know the current password. You've got to ask yourself, is this CSRF generating impact? You know, changing emails and a payment and an article, they're both very high impact. Changing random data, not so much impact. Right, so let's look at some case studies for CSRF attacks. So we'll start with the very basic, like we usually do, and work our way up to something more complex. So this is CSRF apply to this program that leads to submit your request automatic without any validations. This is a very, very simple bug. The form didn't have CSRF protection via a token. Therefore, you could embed this as an image, just like in our demo, and it will basically force anyone who visits that page to apply for that program. And it really just floods a HackerOne program with applications, even without the user knowing they'd applied. So very simple, very, very simple. You kind of standard CSRF. Low impact, yes, but you know what? That's the first bug anyone can get. So then we've got, this is when we start to get a little bit more complicated. So this is using a bit of business logic in there as well. So find an endpoint without CSRF protection, which in this case is for a demo. Realize that you can use this lack of CSRF protection to trick a user via the business logic of an application. Okay, so what does that mean? So you can trick a user into signing up for a trial, but not tell them the trial has expired. So if you think about it kind of as a timeline here, the trial expired here. But you can use CSRF to kind of fake it and say, oh look, you still got the trial, even though after this point, this is all cost them money. So you can see how really the CSRF is quite basic. However, the fact that you can combine that with the business logic to kind of create this larger impact is very, very good. So site-wide CSRF on eats.uber.com. Now there's not much info here, but I think it's really useful to see how a single bug can be really easily escalated by just continuing to test. So find a single endpoint with no CSRF protection. In this case, it was adding new credit cards to an account. A useful bug on its own, they reported it. And actually, but then during more testing, they realized the entire eats.uber subdomain is vulnerable. And none of them had CSRF protections. And this is just an example of kind of taking something that's CSRF very simple and realizing, hang on, this is everywhere, and really upping that impact even further. We got FileUpload Plugin, CSRF, delete all attached files. So another example of generating more impact with CSRF. Here, a CSRF payload is contained within an image like before. However, the image is then the images can actually be used and hosted on the web page. So actually, you can create a post with the image with the CSRF, and then delete it for other users. So super useful, interesting kind of example of a CSRF. Okay, account takeover. So this is kind of a standard CSRF is going to be account takeovers. A lot of people now, if they change your email address, confirm, but actually this is an interesting kind of different route in. So really what this person has done is create an account on third-party software and realized the process for adding or linking the third party doesn't have a CSRF token. So what that means is that you can make a malicious web page that actually links your, in this case, Yahoo account to every single account on the target, which was Discourse. Meaning that when you logged in, and you could click login by Yahoo, it would automatically log you in as that user. So account takeover can even be such a kind of serious bug, can really come from CSRFs. Again, this is an example of generating more impact. A lot of the time with CSRF, you tend to find that you don't get a lot of pure CSRF. You tend to get it exploiting other ways. So here, the CSRF is also a stored self-XSS. So usually for a self-XSS is out of scope, and that's because the user has to type in the XSS payload to themselves. And there's not a lot of security impact with that, because you'd be assuming that somebody would be purposefully trying to do an XSS on themselves. However, if we use a CSRF to send that XSS to the user as if they purposefully executed it. So what we can do is kind of force their account to execute an XSS, even though it's a self-XSS. So here we've got two out-of-scope vulnerabilities, CSRF and XSS. However, actually, there's quite a nice impactful bug there. So CSRF on Periscope Web OAuth authorization endpoint. Yet another example, but ups the impact, and it's quite a simple bug. So Periscope has a developer API, and that's for developers. They can make like other apps. So like on Twitter, you can use TweetDeck. You just need to allow it to use your Twitter username. And as a third party, they need permission, so they need the user to say yes. But actually, on Periscope, this request didn't have CSRF protection, so that meant a user could be tricked into allowing a third-party app to access their account without really knowing. And the reporter here couldn't test too much because they didn't know what the endpoints were. But they did do some vague looking to see you could create a broadcast, tweet a broadcast, or delete a broadcast. Although without knowing all of the API endpoints, because it wasn't public, the impact could be even larger. So here's an example of the cause misconfig to up CSRF. So this app here trusted all domains, and as we talked about, cause doesn't stop CSRF. What it does is it allows you to receive data back. So this app kind of allowed for two-way communication between CSRF vulnerable domains and an attacker. So what they could do is they could just send a bunch of these requests and then get all of the information from a user's account. Even though there are still some protections against it, it was still a nice bug. And they were still able to kind of get some out. So some tips and tricks to finding CSRFs. They can be bugs on their own, but sometimes they're out of scope. However, there are great ways to escalate a CSRF using business logic or XSS, or even just by checking other domains, other endpoints on a web page. Cause misconfiguration doesn't automatically mean there is no CSRF bug. However, it also doesn't mean there is a CSRF bug. So you kind of have, if you see a cause misconfig, you've got to kind of work that out for yourself and work out how much impact you can actually generate. However, if there's no CSRF token, that is where there's a CSRF bug. That's a great indicator. Like, keeping an eye out for that is really important. So I really hope you've enjoyed this video about finding your first bug, Cross-Site Request Forgery, CSRF. And there's going to be one more video in this series, and we're going to be talking about how to generate impact and what impact is. I get a lot of questions about, is this a bug, is this a bug, is this a bug? And I'm going to be telling you what is and isn't a bug. So I hope you all have a great day, and next week is going to be RCUs. Right.